All right, thank you, Vishali. And let's start off and get all the legal stuff out of the way here. Just wanted to make mention that during the course of these webinars, we like to showcase products that are being used in the marketplace and the agencies that are using them. So we will talk about a couple of different products today. The fact that these products are being included does not mean that we are viewing these products as being endorsed by the Federal Highway Administration. We realize there's other applications and products out there that have similar and different types of functionality to them, but we think it does, present a better depiction of what's going on if we can give some actual real case studies of what's being used. So today's agenda, again, this is part of our Adventures in Crowdsourcing webinar series, and we've had over a dozen of these over the last year and a half or so. Glad that you could join us today. Our agenda today is we'll have a little brief introduction of crowdsourcing for operations. Then we'll talk about the applications that the Regional Transportation Commission of Southern Nevada is using Nexar Data for their real-time work zone management, and we'll hear from them. And then we'll have a product overview from Nexar. Then the Maricopa Association of Governments in the Phoenix, Arizona region will talk about their use of Wejo data for monitoring, safety, and planning. And then we'll have a representative from Wejo talk about their product. And then we set aside some time at the end for questions and answers. So I'll ask if you have a question as we go through, please put it into the chat pod, and we'll keep track of those. And then at the end, we'll have a session just for questions and answers. So today, again, I'm your host. I'm Greg Jones. I'm with Federal Highway Administration. I work in a joint capacity with the Resource Center Office and the Office of Operations. Our presenters will be John Peñuelas from the Regional Transportation Commission of Southern Nevada, Brandon Long from Nexar, Wang Zhang from the Maricopa Association of Governments, and Andrew Wallet from Wejo. Unfortunately, Gareth Evans is not able to join us today from Wejo. So just a little bit of background about the Everyday Counts program, and specifically the initiative for advanced operations with crowdsourced data. So Everyday Counts is a 2-year program. It's a state and local based model that identifies and rapidly deploys proven, but at the time that it's chosen, it's underutilized innovation. And the goals of the program are to shorten project delivery, enhance roadway safety, reduce traffic congestion, and integrate automation. So why would you choose using crowdsourced data for operations? Well, it's been proven to improve operation performance. It's been proven to increase safety and reliability. And in many cases, it can save considerable cost to an agency to fill in their data needs by using crowdsourced data. So what are some of the application areas that have been used? Traffic incident management, the detection and response to incidents, providing information for traffic studies, providing information on road weather management, also traveler information data, and using data from crowdsourced data for performance management, being able to track how well the performance measures are being met. Using crowdsourced data to help with signal operations and progression with arterial management. Other application areas are the data can be used for freeway management applications, You can also collect data on work zone as part of work zone management. You can identify both roadway and ITS maintenance needs and apply that to increasing the maintenance capabilities. You can take archive data and apply it to the planning process and use that as a way to prioritize planning projects or the planning process for implementation projects. It can also be used for emergency management. And quite honestly, we see a wealth of other application areas in the future. There seems to be things happening all the time, new uses of crowdsourced data. So today we're going to focus on two specific applications, and the first one is using vehicle video analytic data for real-time work zone management. John Peñuelas is the Senior Director of Engineering for Streets and Highways for the Regional Transportation Commission of Southern Nevada. That's the Las Vegas area. Prior to joining RTC in 2015, John had a 25-year career that included work for the Nevada DOT, the Clark County Public Works Office, and the City of Henderson. So John, let me turn it over to you. Thank you.
Thank you very much. I appreciate that. You can hear me okay?
We can.
All right, very good. So thanks for the invitation. I really appreciate it. The opportunity to talk about what we're doing in Las Vegas with work zone management in general. I'm going to kind of go over our whole program briefly, but then spend the most time on what we're doing with our friends from Nexar on the crowdsourced data specifically. So we signed our first contract with Nexar on the last day of 2018, and we have come a phenomenal way since then, and I think you'll agree. We've got 10 slides, and I'm right at the 20-minute mark, so if you could advance the slide for me, we'll get going. So the, one more? There we go. So yes, who we are. This is, we like to give people a little context. If you click it one more time, I think you can get our boxes up here. So that's good. So I'm told by our government affairs people that we're the only organization that have these 5 roles under one roof, and you'll see why this is relevant in a few minutes. We are the public transit provider for the Las Vegas Valley, both fixed route and paratransit. We're the Metropolitan Planning Organization, so we work very closely with our member agencies to implement the region's long-term transportation plan. For those that might not be familiar with Southern Nevada, our most famous city, of course, is Las Vegas, but we have North Las Vegas and Henderson as suburbs, and unincorporated Clark County, of course, is the 800-pound gorilla in the room. The famous Las Vegas Strip is actually in unincorporated Clark County, and they are a city in their own right, and then 2 satellite cities outside of the valley, Mesquite and Boulder City. So that's what makes up the commission, members from each of those. So we're also the primary roadway and trail funding agency for Southern Nevada. We administer the funds collected from local sales and fuel tax, as well as a role in the federal funding. Of course, the Nevada DOT has the lion's share of that responsibility, but we help out. We're the traffic managers for the entire region. We operate the traffic management center, and that's where we're going to keep our focus for the presentation. And then finally, we are also the bike share. We operate the bike share system downtown, which is pretty popular. So next slide, please. So work zone and lane closure detection, also known as work zone management. The bottom line reason we care about work zone management is because, as I said, we're the regional traffic managers and also the public transit operators. You know, that means that 2 of our 5 core functions can be negatively affected very easily by roadway construction and the associated capacity reductions that come along with the typical lane closures. Now, we've always felt it was important to not put all of our eggs in one technological basket, particularly when you're doing something that amounts to research and development. So we just don't really know which technologies or combination of technologies are going to be the most useful, the most reliable, the most viable. So because of that approach, we've kind of built our work zone management program around 4 independent approaches or pillars. I'm going to go through those 4, and then we'll get into what we're doing with Nexar. So the first is what we call smart work zones, where devices are placed in the work zones themselves that can broadcast out via third-party navigation apps like Waze, but there are others, where the device is and what the status of the work zone is. That's the first leg. The second is devices on the work vehicles that broadcast out, again, through third-party navigation apps or maybe directly into the dashboards of OEMs. The presence of workers in work zones, that's critically important. When is the work zone active? Third, we want to get notified when one of our member agencies issues a temporary traffic control permit, and we want to tie that to an image taken by the person actually setting up the work zone, and then feeding that combination of files to the operators at our traffic management center. This is challenging because the agencies issue tens of thousands of permits a year, so we got to find a way to really focus on the important ones. And then fourth, and this is where the Crowd and Nexar comes in, is our desire to know where work zones and lane closures are occurring in near real time. For our purposes, a couple minutes, 15 minutes is close enough to real time for us, and we can do that. And we don't want to necessarily rely on organizations or other agencies for that information. The other 3 approaches all depend on one degree or another, with the cooperation of others that we don't directly control. Now, there's nothing inherently wrong with that approach, of course, but it's not ideal given the fact that cooperation, it can be a fleeting thing when priorities diverge, and that sometimes happens. So the bottom line is we want to control our own destiny for the things that we're responsible for. And then, of course, the bottom line for all this is we're trying to get a complete picture of all the activity on the freeways and arterials and then feed that information in a meaningful way to the operators in our TMC so they can make better decisions on how to operate the systems we're responsible for. So next slide, please. I'll give you a couple of examples of what we're talking about here. This is your typical smart work zone, and this is on a major arterial up in North Las Vegas. Each of the icons represents a smart device that's feeding its location and status to a proprietary website in this case. And this is Hill & Smith, one of our partners. And the capabilities of these devices is spelled out in our work zone ITS specification that we developed over the years. And anybody that wants, it's in draft form right now. We're kind of testing it, getting the input from industry and the contractors on what can reasonably be expected as far as capabilities, and we're massaging that spec. Anybody that would like a copy of it, we can certainly get it to you, even though it hasn't been finalized. Next slide, please. Okay, that's it right there. Thank you. This is a view from one of the Ptz cameras. This gives our operators at the TMC access to images beyond the reach of the incident management cameras at the intersections. Now we're primarily working with 3 traffic control device manufacturers that build these smart devices. I mentioned Hill & Smith, but we also have Icone and Burmac supplying equipment. Now they have a lot of experience on the freeways, but this is kind of a new animal, bringing that technology onto the surface streets, and we're kind of learning as we go. Next slide, please. So the second leg of our work management program is the ability to know when workers are on the job and when the work zone is active. This is important for several reasons. So our partner in this effort is HosAlert. We've been working with them since May of 2019. They got started with emergency services with a system that could broadcast the approach of the emergency vehicle via Waze to people, to motorists that are potentially in the way. So they get a direct connection to the emergency vehicle, and they get the warning from Waze well before they hear the siren and see the lights to get out of the way. So when we were introduced to this technology, we were wondering if we could turn it around. Instead of warning people that they are being approached by an emergency vehicle, could we warn people that they are approaching a work zone or a utility vehicle? And Haas has worked with us, and they are moving in that direction. Well, I shouldn't say they're moving in that direction. They have that now, and it's pretty useful. So this is just next slide, please. This is just a dashboard. This shows 7 of our vehicles, where we put them on our vehicles just to get an idea how this worked, and we could then put the capability in our work zone spec. And this shows 7 vehicles, 4 of which have amber lights on, so that could be an active work zone. So that's important for us to know. It also enhances the safety of the people that are working in the work zone. So next slide, please. This is our network occupancy management proof of concept. We just hired Ludian Consulting to help put this together. And what we're looking for here is we're trying to marry up the temporary traffic control permit with the local agencies with the work zones, or with a picture from the work zone as soon as the work zone is put down, and then put that in a dashboard like this and feed it up to our traffic management center operators. So like I said, this is a proof of concept, another avenue to get the work zone data into the hands of the TMC people. All right, so next slide, please. So this gets us into the 4th component, which is the crowdsourced data. Nexar came to us in 2018, showed us the technology, and basically asked us if we saw any use cases. And I, being a traffic engineer, said, help us find the lane closures. That's kind of tricky. You'd think that the permitting agencies and or the traffic management organization, us, would know exactly where all the work zones were at any given time. But unfortunately, that's not the case. We have a sense of where they are. We can estimate where they are, but it's a guess at best. And even if we were to know, it's not on a regional platform that everybody can see. So the bottom line is the agencies know where the permits are, and the RTC knows where the construction projects are, but we need to know where the actual work zones and lane closures are within the permits, which could be a 90-day window, or within the project, which could be a 2-mile-long stretch of roadway. Where are the work zones precisely? So that gets us into the user interface. That you're seeing it right there, CityStream. Now, this gives us an overall view of the construction in the valley based on their network of interconnected dash cams and AI. Now, this is completely independent of those 3 legs of the program that I mentioned before. So we're in complete control of this information. The dash cams are able to pick up temporary traffic control devices, and their very smart computers are able to determine how those individual cone detections fit together to form a work zone. And then they can estimate if the work zone is causing a capacity reduction. And if it is, it shows up as an orange dot on this map. So they're covering about 100,000 miles a day, those dash cams, which is great coverage. And obviously that's a question that we always get, how much coverage do you have? And we're getting multiple hits on the big roads, dozens of hits a day. So the coverage is good. So as it turns out, there are between 400 and 600 impactful work zones in the valley, reducing capacity on any given day. And on this day, which I think was July 7th, there was about 573, it looks like. So in the past, there was no way to measure this directly. It was basically an educated guess. So now with the crowd on our side, we can measure this directly. And as everybody knows, you cannot manage the thing that you cannot measure. So this was the very first step in trying to manage the work zones better. Next slide, please. So if you zoom in on one of those dots, you're going to see orange lines. This is, and these represent potential work zones found during the time frame specified over there in the left-hand corner. This is Sunset and Decatur, which is right next to my office there, the Nevada DOT facility right there. And if you click one more time, next slide, you'll click on one of those orange lines and you're going to see something like this. You're going to see these images of where they've detected these individual cones, in this case these candlesticks. And you're going to get dozens of images. This is typical on-site work that's having an effect on the roadway. The work is very near a traffic signal, and it's affecting operations to the point that it's backing up traffic, not in this particular case, but a little later in the day, up an off-ramp on one of our freeways. Now, we should have been notified that this was out there per the conditions of approval with Clark County in this case, but we weren't. And that was because they were closing the number 3 lane and the right turn lane. That doesn't usually mean that there's any signal modifications, the timing that needs to be done. But unfortunately, this was so close to the freeway that we needed to know, and we were not informed. So if you click one more time, you can see that this is, or that one that we just had, that was June 15th, and that was the first image that we found that showed that open trench. And that is a problem. That should be protected. And then this is 6 days later on June 21st, and it's still unprotected. One more click, and you'll see, the real problem. This is on June 22nd, and this is the view from one of our incident management cameras, and we've got 4 people completely exposed in this trench. And anyone that's seen a crash at a big high-speed intersection knows that people end up in the corners when they come together. So this is a very clear violation of the Clark County's permits and conditions of approval, that if you have an open trench, you got to have some protection. So this story has 2 points. First, it highlights the ability of the Nexar dash cams and artificial intelligence to find work zones that we did not know about, and gives us a very detailed look and information on when and where it was set up, time certain, and the condition that it was in at that time. Now, even though we were surprised by the work zone and lane closures in this case, we could have found it on our own using the City Streams, UI, and we're working on some enhancements to that to make it even more automated, and we'll get to that in a sec. The second point is that it gives the permitting agencies, in this case Clark County, the documentation to issue a fine for the violation of the condition of approval. They can show exactly when that open trench was there, date and time, photographic evidence, so there's no argument that there was an issue. And I haven't heard the status of issuing that fine by Clark County, but I'm sure that it's coming. So now the thing that we're working on enhancing is we want to bring that Nexar data. They have an API, and we want to bring that work zone data into our data integration and predictive analytics tool called Waycare. Some of people may be familiar with Waycare. It's another Israeli outfit that we've been working with for a few years now, and they've been helping us on the freeways. We manage and operate the ITS devices on the freeways on behalf of the Nevada DOT. Now, Waycare can integrate data from many different data sources, and it gives us a greater awareness of field conditions. So once that platform, once the platform with the work zone location data is in the system, it can be superimposed on the congestion data that Waycare is also bringing in from probe data, essentially. And now you can marry those 2 things together. A red line is starting to develop on this section of Decatur. We know it doesn't matter if we were told by the permitting agency that this work zone was coming. We know from Nexar that it's there, and now that alert could pop up and call specifically to the operator. There's something brewing on Decatur and Sunset. Get an incident management camera on it. Figure out what it is, get Clark County on the phone, figure out how long this is going to be there, tell them that we need to get some barricades out there on this, or barriers in this case to protect the trench, and down the road they go. So that's it in a nutshell. Now, I do have, according to my watch, about 2 minutes, so I wanted to go through, if you click one more time, I wanted to show a couple more examples of how we're using Nexar. This is downtown Las Vegas during the pandemic, where we've got an outdoor restaurant set up on the street and a left lane closure. This was probably permitted. Everything's good. The point is that this could be observed and checked off as being good from the office rather than having an inspector driving around looking at this thing. So this is a force multiplier for our member agencies. The next one is another example of that, where we've got some orphaned traffic control devices, we call them. So instead of just stumbling across this as the inspector's making his rounds, this could be found in the office. They look at who had the last permit out there. Barricade company, they call them up, hey, get your cones cleaned up. We need those parking spaces. And then the final slide is an example of some barrels that are blocking the bus there. It's not blocking the bus turnout, but there's probably a work zone, downstream of this, but it is forcing that bus out of the travel lane. Now, this is important because we could get this picture over to our traffic ops folks and say, hey, there's construction activity out there. You may or may not be aware of it. Again, they're supposed to call, but they don't always call. And now our traffic or our transit operators can be made aware and make sure that if that cones move around and that barrel starts blocking a bus stop, they can take corrective action right away and not have to wait for the bus driver to find it. By that time, it's already too late. The customers can't get on the bus, and that's a problem. So we need to identify these things as fast as possible. So the final slide is just my thank you for the opportunity, and hopefully we were able to show you, give you an overview of our work zone management program and how the Crowd can help us improve the signal and transit operations in Southern Nevada. So I appreciate it very much.
All right, thank you, John. Excellent presentation showing some of the applications and work zone that you're doing there in the Las Vegas area. I just want to remind everybody that if you got questions, go ahead and throw them in the chat pod. We'll get to them either at the end with the question and answer session, or if it can be answered with a quick short answer, we'll put them into the chat pod. One of the things that we're having to do is kind of a workaround for one of the issues with the platform we have today. John actually can't type into the chat pod, but he has access to send answers to Vishali. So if you see an answer from Vishali, it will be relaying what John's answer is to the question. Again, if you got questions, put them in the chat pod. Our next speaker is Brandon Long, and Brandon is the Director of the Public Sector and Smart City Innovation at Nexar, and he leads Nexar's vision of delivering its images and AI detection to cities, DOTs, and more. So, Brandon, let me turn it over to you.
All right. Thank you so much. Can everybody hear me okay?
Sounded good.
Wonderful. Okay. So it looks like we've already got some questions about Nexar technology in the chat, and I'm really hoping that I'm going to be able to address everything within the presentation, and if not, really looking forward to the Q&A. But what I'm going to talk about today is how Nexar has created a network of connected dash cams to be able to collect anonymous imagery and process it to make it available on a platform that the city, states, and local DOTs have been finding very useful. So for those of you unfamiliar with Nexar, the essence of Nexar is kind of twofold. On one hand, we are a hardware company. We've been selling a connected dash cam that is very affordably priced and very easy for our consumers to use so that they can place it into their windscreens and record their drives in the event that they need to prove their innocence or lack of liability in the event of a car accident. We've been very popular with, specifically with professional drivers. Uber and Lyft drivers use this frequently, truck drivers, and even folks just like you and I who, well, myself, who likes to record their drives just to make sure that I'm covered in the event of any kind of liability. We're the #1 selling dash cam on Amazon. We have about 10% of the market share in the United States right now. Which has allowed us to be able to create a network of over 80,000 weekly active drivers that map out over 100 million miles worth of road in the United States every single month. So what we're doing here is the dash cams collect images anonymously that we place into this platform that cities can then use to be able to develop use cases just like John showed. So the idea being that the dash cam is connected to a user's smart mobile device and uploads into the platform. Just kind of showing you what the tech stack looks like, that that camera is mounted in the windscreen. It then connects to the user's mobile device, and the mobile device uploads interesting frames, incident videos, and time-lapse videos into the Nexar cloud. Now, the Nexar cloud is really kind of twofold. The first is going to be the individual driver's cloud, and that is going to be, like myself, I have a dash cam in my vehicle, and I can access any of my videos recorded anywhere in the world from my smartphone, as long as I've got a connection to our AWS cloud. But then the Nexar cloud, or the city stream cloud that agencies can access, these videos also ingest key images from the videos. We localize them, we run our detections through them, and then we completely anonymize them to be able to conform with GDPR and CCPA standards. So we do take anonymization and our users' privacy very seriously. We do not put any information online that is going to end up being personally identifiable. The idea here is that we are trying to get agencies to take more of a proactive stance as opposed to a reactive stance, being able to detect issues and complaints before they end up coming in, which allows them to better engage with their citizens and prioritize fixes based off of facts. It also helps save maintenance and surveying costs, and as JP did a great job of showing, we can help enforce permits and rules more effectively and actually become a revenue generator in certain circumstances. So with this imagery, we've really been able to develop 3 key use cases. The first one being just the raw imagery, being able to see the images as we're able to collect them, and the images themselves are placed on the platform about once every 15 minutes or so. The second being detections, and I'll run through a couple of different types of detections that we have here in a moment, but that is our ability to be able to see things like construction zones, like roadway barriers. We can detect street signs, and we're also working on several other detections right now, including potholes and guardrails. And then the third being the change detection, which JP also briefly touched on. So we can see, say, from one day to the next, taking construction zones as an example, we can see what the difference is between the construction zone that we saw on one day and the construction zone that we saw the next day. So if it has expanded in scope, we can actually report those changes and place them onto the platform for agencies to be able to see what's happening in their areas. So showing you the first product, or just talking about it a little bit more. The first product is going to be imagery, and we call this virtual camera. So through a series of hexagons that we have overlaid over an OpenMap, you're able to actually click on a hexagon on any given area to be able to see images that we have collected in that specific area over the course of the last 30 days. We can also create if you see this little purple square here in the middle of this image, we can also create what's called a virtual camera, which is a high priority zone that is going to increase image collection rate in this specific area and be able to organize it in a way that makes it easier to be able to view. So take, for instance, if there is going to be an expected traffic incident due to an event near a casino or near the new sports arena out in Las Vegas, JP would be able to create an area around a specific intersection to be able to have better eyes as to what's going on in near real time. The second product, talking about change detection. So our road work zone tools have actually been able to create a better workflow for agencies as well. That allows agencies to be able to better see what's going on and what's impacting traffic in their specific area as well. Our road work zone detector is able to not only see the images of the equipment that is placed in a specific area, but we can also provide analytics on how it's impacting traffic, what traffic flows are doing through the area, when it begins, when it ends, both geographically but also time-wise. And we can also see if lanes are closed off in a specific area. Next product that we have is going to be our road inventory, and this is our, I briefly touched on this a moment ago. Currently, our road inventory is set up to be able to detect the presence of street signs and where they're laid out in a specific geographic area. This allows agencies to not only have a compiled database of what street signs are deployed where, which is very important, especially in areas where there may be several agencies that are responsible for the deployment and maintenance of street signs, but to also see if there's been any changes that have happened from month to month or week to week, depending on how frequently it's run, so that they can better manage the inventory and the status of their street signs to be able to keep traffic flowing and limit liabilities. The last product that I want to talk on just very briefly, and unfortunately the video I sent is not working here, but we're currently in beta testing right now for a parking and curbside detector, which is completely visual based and allows agencies to be able to see what's happening in their cities in near real time. So our parking detector, we were able to filter out in our test area. We ran this back in February in partnership with the city of Milan in Italy. And when we filtered the information that we had through accurate curbside parking information that the city provided, we were able to locate parking spots with a near 90% accuracy with a 90-second latency between when a spot was detected and when it was pushed out via API. We were also able to detect a spot every 8.4 seconds using a fleet of about 50 cars, which is a very, very small fleet. To give you an example, in Las Vegas alone, we have several multipliers of that. We probably at this point in time have close to 1,000 vehicles within the Las Vegas Valley. So the very little coverage is required to be able to have a product that's going to be very effective. So with my last minute here, I'm going to show you just a few images that we have that show the difference between the images that we provide and the images that are provided with a service like Google Street View. The big difference between us and Google Street View, aside from the analytics that we're able to run, is the freshness of our data. Oftentimes in major cities, we're able to provide data several times per day, as opposed to Google Street View, which is going to be roughly about once every 2 to 3 minutes. So what you're going to see here on the left-hand side is going to be a Google Street View image. On the right is an image of the same intersection, which obviously has different traffic flow patterns, and we've got a block off on the lane here on the right-hand side now. We have here same situation. Right is our image, left is Google Street View. We have a protected left-hand turn lane now. We're able to see construction zones as they're blocking off a lane here actively on the right-hand side. This type of information and this type of data in near real time has been very effective and very critical to the impact of workflows with the agencies that we've been working with. So with that, I am at my 10-minute mark. Thank you so much for allowing me to speak. If anybody would like to reach out to me directly at the end, please feel free to get in touch with me, and I'm happy to answer any questions in the Q&A. So thank you so much.
Thanks so much, Brennan. Thanks for giving us better insight into to Nexar and the applications that your products have. Again, I'll just remind folks, if you've joined late, please put your name and affiliation in the chat pod. And again, if you got questions for one of our speakers, put that in the chat pod as well, and we'll either get you a written answer back in the chat pod, or we'll discuss it during the question and answer session at the end. So next up, we have Dr. Wang Zhang, who's the Transportation Data Program Manager at the Maricopa Association of Governments. He received his PhD in Civil Engineering from Virginia Tech. And for the last 15 years at MAG, his work involves transportation data collection and processing and applying data analytics and visualizations to system analysis, transportation modeling, and planning studies. So please take it away.
Thank you, Greg. Can everybody hear me well?
Yes.
All right. So, at MAG, we are the planning agency at the Phoenix metropolitan area in Arizona. It's been a while that we noticed that, we have been working with more and more with the crowdsourcing data, either directly with, working with the crowdsourcing data or, working with some products, developed by some companies from crowdsourcing data. So it's really exciting for us to have this opportunity today to kind of share some of our experience working with one of the crowdsourcing data, connected vehicle data that is provided by Wejo in terms of how we apply, Wejo data into our transportation modeling, monitoring, safety analysis, and the planning studies here at MAP. Okay, today I want to specifically just talk about two major points. Obviously, first is I just give you some introduction of what is MAC and what kind of the connected data, vehicle data we receive from Wejo. I know that Andrew from Wejo who's gonna present after me will have very exciting contents about all the different products and services provided by Wejo, but I will just limit it my talk about the connected vehicle data for what we have received and what we have analyzed. And then the next part of my presentation, I will just showcase some of the projects and studies that we have used. We use the connected vehicle data for, and specifically, I'm going to talk about how we apply connected vehicle data into a certain performance measurements, analysis, how do we run the project evaluation with Wejo data, and our freeway bottleneck study has also used the Wejo data as main source just to help us understand origin destination patterns for our certain bottlenecks here. And we also can analyze the queue with Wejo data, and it's just a really versatile data sets. We apply that to certain travel monitoring through the COVID, and we also use that to benchmark some other third-party speed data we have been using, and transportation modeling, travel demand modeling is one of the major core business here we do here at MAC, and certainly we also try to bring in Wejo data to help us with some of the modeling work. So those are the main topics I would like to go over with you guys today. So very simple, MAC, Maricopa Association of Governments, so-called MAC. We are the Phoenix metropolitan planning organizations here in Phoenix, and our region has about close to 5 million populations, which is consisted of 27 cities and 3 native nations, so in Arizona. So what is the connected vehicle data, and specifically what is the Wejo movement data? There's a different kind of connected vehicle data we're talking about, but today I think my presentation is going to focus on vehicles movement data, and the applications I'm going to talk about is going to focus on how we apply those movement data for our planning studies, because the data we acquire from Wejo is archived based. It's not the real streaming data. So we receive the data for the past months, for example, only from the archive standpoint. So the data just comes in with a really large volume, but with very simplified fields. So basically, it's giving you individual vehicles travel trajectory update every 3 seconds. So the data, like I show on this screen, has very simple information: the timestamp, geo position of this vehicle, how fast they're traveling, and which direction the vehicle is heading to. And it's coming from, based on our calculation, from roughly 12,000 to 14,000 vehicles per day that is kind of running as a probe in our region, collecting data for us. And it's for passenger vehicle only. So the data does not contain anything from medium or heavy trucks. And the specific data fields could also vary, based on how you talk to Wejo, and what we receive is just like what you're showing, what you're seeing right here. Just give you a kind of perspective of how good the data coverage is. So I'm showing you the data coverage in our region at 1 a.m. So pretty much 1 hour after midnight. So this is kind of one of the lightest hours in terms of the traffic. But as you can see, the data still pretty much cover our major roadways here in our region. And if you look at that really small blue frame, and if you zoom out, that's how the data look like. So every 3 seconds, you have an update of the vehicle trajectories. So this is at the lightest traffic, time of the day, pretty much. And for individual vehicle trajectory or individual vehicle trees, that's how it looks like. This graphic actually showing on the left one vehicle entering a particular freeway bottleneck zone, and from the top left-hand corner, and exit at the bottom. And you can basically just look at this vehicle's, vehicle and position and how fast they're traveling every 3 seconds. If you put it on the map, it's really identify certain fidelity of the real traffic conditions at that particular time. So, like I said, we have roughly 12,000 to 14,000 individual vehicles connecting such kind of data in our region. That is all provided by Wejo. So essentially, it's like a running, tons, thousands of, probes, 24/7 for us, for different kind of transportation-related analysis. That's why we are interested. Okay, talking about the sample size, I already mentioned how many the number of vehicles, and that compared to our, universe here in our region, it's about 4 to 6%, depending on time of the day and which particular areas. We generally notice the sample size a little bit higher on the freeway, and slightly lower on the arterial, but on average it's about 4.5%. Like I said, it's 4 to 6% in our region. This number of sample rate could be different by region, by state. I know that Wejo could achieve a higher sample rate in somewhere else in the country. But that's what we observe here in Maricopa County in Arizona. Okay, so speaking of how we apply the data, this is kind of high level of the summary of what we have been doing or what we plan to do, applying this connected vehicle data into different transportation related analysis. I'm going to touch on some of these bullet points in the next 10 slides. But this is just really high level of what we plan to do with the Wejo data. Okay, the first, performance measurements. This one is specifically about intersections analysis. You have, tons of the cars running past arterial intersections, and we can really utilize this data to calculate the turning movement ratio. And more importantly, something that is really hard to connect in the past without the connected vehicle data is to calculate the travel delay, the vehicle's delay by different turning movement and any given time of the day or any given day of the week. That was very, very difficult, or it's very expensive to connect if you were running the probe car technology trying to do that. That's very, very time-consuming, labor-intensive project. But now with this wonderful connected vehicle data sets, we're able to kind of use the Wejo data to see how good the intersections works in terms of dealing with congestion, and we can even rate the intersection level service very easily, by time of the day, and we actually compare this to other sources we connected somewhere else, and it shows pretty high correlations. Okay, next application, when you're expanding your analysis at intersection to a certain corridor, for example, arterial corridor with a bunch of the intersection all connected together, especially if you do a certain signalization optimization projects study, and you want to evaluate how effective this project has done to this particular corridor in terms of dealing with congestion, or in terms of moving people or cars, more smoothly throughout the corridor. We typically run, before and after study to evaluate that. Now you can do this kind of study using connected vehicle data sets. And this is just a simple comparison of the time-space diagram, which essentially is putting the dynamic of vehicle's trajectory into X and Y and to do some quantitative analysis to it. And this is in comparison of, connected vehicle in blue to floating car, technology in yellow. So as you can see on this graphic, connected vehicle data definitely provides you with much better, samples of the car running through these particular corridors on both directions to help us understand what is really going on, at this corridor. And floating car can only do that for very limited, runs with very limited days. But like CV, connected vehicle data, allow us to do that on any given time, on any given day, as much as we want. Okay, select link analysis, especially how we analyze for particular, in this case is for a particular freeway segments. We want to understand where do people travel from, where do people go at a given time of the day. We can use the Wejo data to help us answer that. I'm gonna flip through a few images. So the previous one was in the morning, and then at the midday, and at night. Don't want to spend too much time on this graphic, but basically, the Wejo data help us to understand, what is the market of a certain, roadway segments. And specifically for the freeway bottleneck analysis, we can easily identify the queue using Wejo data. In this case, we define stop point as any vehicle traveling with a speed lower than 3 miles per hour. So that's being symbolized as the yellow dots on the graphic. And you can look at that on any given time and day, and then just analyze how long the queue is and the dynamics. How does the queue interact with the time of the day, and how do, like, for example, two queues merge against each other, stuff like that. That has been really useful information for us to understand the cause of the freeway congestion or the cause of the freeway bottleneck. So that's another case of interaction between the main line of the freeway traffic and the traffic coming from the on-ramp. So we notice in this case where the on-ramp traffic really impact the shoulder lanes of the main traffic on a particular segment of the freeway. And this one, basically, because every 3 seconds there's an update of the speed, it's very easy to calculate your deceleration or acceleration rate per vehicles. And with certain massage of the data, you can identify where the Heartbreak is made at certain freeways or arterial streets. If you run that on the entire region's network for a very extended duration of the time coverage, you're able to potentially identify some vulnerable safety zones where people intend to hit the safe Heartbreak more frequently. In this case, what I'm showing is, again, on the freeway bottleneck by different time of the day, where do we observe the Heartbreak occurrence at this particular bottleneck. Travel monitoring trend analysis, throughout the COVID, we were, trying to, look for any, reliable, continuous data source to help us understand how people has traveled, or right now to help us understand how the people has transitioned in terms of their travel habit. That's something connected vehicle data can help you understand in terms of your trip frequencies, the distance you drive per day, and what places have you been visiting throughout COVID and going beyond. In terms of the distance travel, we did compare Wejo-based analysis to like our permanent traffic counts data, and they show great correlations as well. And then this is another case of, like I mentioned, benchmarking other third-party speed data using Wejo data. We noticed that during free flow conditions, those two different kind of data in turn to agree with each other much more. than the congested time, in which case, the third-party data from here, in this case, would underestimate the congestion as compared to, what's being reported by Wejo. Vehicle fleet composition, we know, what this data is composed with. There's about 40% of them, at least in our region. That is from the pickups, and another, close to 30% is like SUV or MPV, and the rest of them are all passenger cars. And 86% are from gasoline, and the rest of them are others. And they're all like 2015 or newer. So that has some model implication in it, because we maintain our travel demand model. In our travel demand model, there's something we care about is called vehicle fleet composition model. We want to know what kind of cars each household has, where do they travel, how long do they travel, stuff like that. So in this case, Wejo data serve as a supplemental reference to help us calibrate our model. We would know, by different vehicle type, what is the histogram distribution of the distance they travel, and on average, how much time they spend on the road each day, etc., etc. All right, so I think I'm getting to the end of my presentation. So basically, just to recap, we think the connected vehicle data provided by Wejo is really versatile. It actually helps us, do different kinds of exciting, analysis and studies in terms of monitoring or analyzing traffic and travel. There is definitely a big gap between the road data and the information that is digestible to stakeholders, which means the agencies need to prepare a significant amount of time and effort with capable staff to kind of bridge the road data to the digestible information together. And since this is still a fairly new data set, we haven't really identified any, matured or, sophisticated platform to help us, leverage the data more efficiently, but it's definitely on the horizon. We need to keep eyes on that. And then there could be some new OEMs or other, data providers getting into this game. To us as a data consumer, it's always good news because we get to work with more data. So the higher sample rate is always better. With that, I would like to conclude my presentation. Here is where you can find me if you have any additional questions, or I really look forward to the Q&A session later. Thank you very much.
Okay, thank you, Dr. Zhang. Certainly appreciate your information about the analysis of what you're doing there in the Phoenix area. And with that, we're going to move on to Andrew Wallet. Andrew's with Wejo, and he works closely with the commercial and technical team to bridge the gap between client needs and data capabilities, and he relies on his strong sales background to be able to identify and fulfill a variety of use cases for Wejo's end customers, and pushes the boundary of what's possible with connected vehicle data. So we'll be happy to hear what you have to say, Andrew.
Perfect. Thanks. Thanks again for the introduction. Long, great presentation that you provided. So happy to provide a little bit of background today on the Wejo data sets. Appreciate that Wong went into some of the practical use cases that can be accomplished using the connected vehicle data that Wejo has. So diving right into things, just to give a quick background, what Wejo is we are a connected vehicle data exchange platform. So what that means is there's a group at Wejo that goes out to all the auto manufacturers of the world. We're in agreement with about 15 of them at various stages, 3 currently in a production environment, which are contributing to that 11.2 active vehicles throughout the U.S. that we are currently collecting data for. And some of the other key statistics that you're seeing on the screen are contributed from those vehicles. So looking at things like 354 billion miles curated, 66 million journeys analyzed per day over about 12 billion data points on a daily basis. So diving into what I was just saying previously, Wejo helps provide data from different auto manufacturers, not just in the U.S., but globally as well. So how this works is we are not putting on any aftermarket device, dongle, Bluetooth sensor to the vehicle. We're taking data directly from the auto manufactured installed IoT sensors that were installed upon the assembly line process, streaming them into our cloud network via the cell networks of the world, so the 4G, 5G, the LTE, and then we stream those out to our end users in a variety of different ways, but the real-time capability that we have with the data would be getting 95% of our data to our end users in less than 30 seconds. So just picking up on that point I just touched on, there's numerous different ways that we are providing data to the end users we see in the space. The live feed of data is something that, a benchmark that we've established that we've been trying to provide the marketplace with as much real-time vehicle data as we can. When talking about what MAG is currently doing, what we help provide MAG with is different forms of archive data or batch data from various points in time, which allows them to help build out their travel demand models and various other applications that MAG touched on during their presentation. So you're seeing that as two ways in which we are able to send out the raw vehicle data that we do have. An interesting point that Wong did touch on would be that working to find a platform or more digestible ways to utilize that big vehicle data, as I could already see some questions in the chat with, you know, how much resource you have to dedicate to this, because we understand that it's a big undertaking to digest, analyze, and make useful insights of the raw vehicle data that's coming off our vehicles, like I touched on previously. It's a lot of data. So our marketplace strategy has developed over the past year or so, in which we're providing different aggregate and platform outputs to help the data become more digestible. So we're providing CSV outputs for both our traffic data and our journey data, and we are working on a SaaS-based platform in which we are launching, we're hoping at Q4 at the end of this year, and we've also developed a larger partner network with the likes of Waycare, Iteris, and a few other folks that are helping some of our public sector end users utilize some of their pre-developed applications to digest the Wejo data. Oops. And just moving forward, wanted to just quickly dive into the top level of the Wejo data set. So our data is currently comprised of two disparate data sets, which is going to feed into all our products, all our partners moving forward. The first of which would be our vehicle movement data set, and the second would be what we call our driver event data set, which I will come on to shortly. So with our vehicle movement data set, this is by far the densest of the two data sets, and it's probably the largest of any kind in the world. So the vehicle movement data set is made up of a 3-second capture rate from over those 11.2 million vehicles across the U.S., which is being streamed 24 hours a day. Then due to this 3-second pulse, we're really able to accurately know not only the origin and destination of the vehicle, but the precise route that vehicle took to get to that destination. Additional attributes within this data set are the lat, long, speed, heading, which can build that rich picture of what congestion looks like, not only on those not only on those major roadways, but the surrounding tributary roadways as well. And then I believe this is a still picture, but if I were able to play the video, the image would really show that the trajectory, speed, and the general overall mobility of that specific stretch of road. And then just one final element I wanted to call out within this data set is we are able to extract the vehicle make, model, and year of manufacture through an obfuscated VIN number. So this is especially important with understanding the types of vehicles that are using particular roadways and could be a good indication of road condition. And moving forward to that second data set, driver event data. So unlike our movement data, these data points are sent at ignition off and ignition on. So we have gotten this down to stream every 12 hours throughout the day. This isn't a real-time data set yet, but we are working on that. Typically, this is received in a batch or a drop format. So two of the most unique attributes that are going to be included within this data set would be the harsh braking and the rapid acceleration. So these events are triggered when thresholds in the vehicle are met, and they're a pretty good indicator of a hazard detection or a specific roadway condition. So the still image, it's a little tough to see, but it's going to demonstrate the combination of rapid acceleration and harsh braking in Austin over a 5-hour period of time. And the culmination of a lot of these events occurring in a specific area are typically that indicator of there's a proactive approach that will most likely need to be taken to amend some sort of roadway hazard that is currently there. And then with this data set, we are working to incorporate a few different attributes from some of the newer OEMs we are onboarding. So we've really moved past the two clear harsh braking and rapid acceleration data points to where we're tracking things like exterior temperature, wiper status, fuel consumption, odometer. We do have an ABS braking point in there as well. And this will continue to become more and more robust as we continue to onboard additional auto manufacturers to our data set. And then just a quick last slide, as I know I'm coming up on time. I like to highlight the difference as Wejo often draws comparisons to some of the similar mobile data sets that do exist in the marketplace today. So our 1 to 3 second capture rate with that 3rd and 3-second latency is a definite indicator of providing value to the current end users that we do service, such as Maricopa Association of Governments. The high volume of journeys helps to provide and explain any sort of bias that may be within the data set that we are providing. The accuracy is something I do always like to touch on. Our data points are accurate to every 3 square meters. So this is where we're seeing a lot of value to where for example, we're able to see something as granular as a car parked in a specific parking spot to a car driving in a specific lane on a roadway. And then the fourth and final point that I wanted to cover that I did touch on from our driver event data is that the data from these historical events is able to give an additional layer of detail to a very important use case to a lot of folks, and which is that safety environment. So explaining why wrecks happen and, you know, potentially preventing wrecks and accidents that occur upon roadways. I believe, you know, a stat we like to use a lot is something that was derived from one of our partners in Purdue University, and they derived that for every 147 harsh braking events, 1 accident does occur via the Wejo data set. I believe that was my last slide, and I am right at time. So going to turn it back over to whoever is next.
Thanks, Andrew. So actually, you were our last speaker, and so what we're at now is the question and answer session. And I know we've had a number of questions that were put into the chat pod, and some of those were answered, but let's just go through them and see if there's any additional information that our speakers want to add. And we have about 10 minutes set aside for this, so we can go through this and get to as many as we can. So the first question was kind of a series of questions about Nexar. What is the data processing time for updating the pictures, and how is the quality of the data checked and implemented? And then there was a follow-up about does the number of data sources have any effect on these quantities? So Brandon, I know you answered some in the chat pod, but do you want to expand on that some?
Yeah, absolutely. So the frequency of data updated in the platform really does have to do with what the coverage looks like in a specific area and also what the agency's use cases are. Images placed into the platform that I showed on the virtual camera product, so just raw images, click on a hexagon, be able to see the area. Those are updated as they come in. Oftentimes in an area like Las Vegas, it's oftentimes about once every 15 minutes or so, depending on how frequently traveled the road is. For detection products, like the construction zone detection that JP showed off, that is updated every morning at 5 a.m., and that is based off of the previous day's aggregation window. This can also be based off of a one-week aggregation window in areas where traffic is a little bit lighter to still be able to show a large data set that agencies can be able to pull information from. The road sign detection product that I showed, or really any of our detection products, those are also updated based off of what the agency's needs are every week, every 2 weeks, or every month. They're kind of the most frequent. And then the coverage in an area is really going to end up impacting how frequently we can end up updating the data as well. The coverage in an area is oftentimes going to be best in higher traversed areas, so say the I-5 in California or larger to mid-sized cities. But there are a lot of things that we can do to be able to increase coverage in an area where an agency wants to do business with us, such as increasing the organic collection rate of the cameras that we already have deployed, working with our partner companies at Uber and Lyft to be able to deploy more cameras, or working with our in-house marketing department to be able to sell more cameras direct to consumers via our Amazon web services, or I'm sorry, Amazon product services.
Okay, thank you, Brandon. And then there was a follow-on question. It says, is there any possibility for detection of critical road designs like wrong way movements through your system? Is the processing time fast enough that you could get that information to the agency and they would be able to act upon it?
Yeah, that kind of depends on what the individual use case is and how quickly they would need that data. It would also depend on what kind of coverage we have in that specific area. It's absolutely something that we could work with an agency on. I hesitate to say a firm yes or a firm no unless we kind of scope it out, but I can say that it is within our wheelhouse and it is something that we could absolutely work with an agency on.
Sure. Okay, thank you. So let's move to Andrew. There was a question about what is the Heartbreak analysis based on? So can you expand upon that just a bit?
Yes, so the Heartbreaking is derived from our driver event data set. I forget the exact metrics that are derived, but any time that the specific threshold of the Heartbreaking metric as set out by our data science team is met, that would trigger a ping with the event type name. In this case, it would be driver event, the lat, the long, the speed, the heading, the date and time of when that specific event would occur. And I could go offline just to confirm what the specific metric is that does set that event off after the call, and I can provide it.
Okay, thanks.
Mm-hmm.
All right, so let's go to Dr. Zhang. How many personnel were you able to dedicate to the analysis of the connected vehicle data?
Yes, so I think I already answered that in the chat box. I believe all the questions dedicated to me, I already answered that, but I can repeat that. So we are a small team. We're in charge of data processing analysis for all kinds of traffic or transporting data, Wejo being one of them. It does cost us most of our attentions in the last 12-month span. As compared to other tasks we were working on, but I think the most of the stuff I show you were done just within 2 to 3 persons.
Okay, well, thank you. And like you said, you did answer the other couple of questions that were specific about the type of analysis products that you were using. So
Yep.
With that, I think we've gotten to the main questions, and we probably are just about right on time. If we can move back to the original slideshow, we still have a few slides to hit there. Okay. All right, so just as a resource page, the Everyday Counts program focuses in on getting out technical information and providing information to the states that are implementing crowdsourcing for operations through things like workshops and peer exchanges. We do provide technical assistance to the state and local areas when they have specific issues. We have started a program called the Crowdsourcing Cohorts, which we're looking at 3 different application areas. And we actually have a cohort meeting scheduled for tomorrow on navigation data. And so that's basically an opportunity for folks that are engaged in this initiative to talk about things that they're doing and just have an informal exchange about questions that they may have on what others are doing and such. So that's certainly a great opportunity to be involved with. The webinar today is part of the Adventures in Crowdsourcing webinar series, and we do have a fairly regular program set up for this. Today is the second Tuesday of the month, and that's generally the time that we shoot for each month to have one of these. And I know we're working towards putting together a webinar for August 10th. So look forward to an announcement for that coming before too long. And all of the webinars are recorded. So if you go to the Center of Excellence website, you can find previous recordings of other Adventures in Crowdsourcing webinars if you want to check in with those and see what other topics were talked about. The Everyday Counts program has a website, and that website features information on all 7 of the initiatives that are ongoing for Everyday Counts 6 currently. And Everyday Counts Round 6 started at January 1st of this year, and it's a 2-year program, so it will continue on until the end of the year in 2022. So there's good information on all of the initiatives, fact sheets, frequently asked questions, and some sample applications and use case scenarios that will be provided on that website. And finally, there's the opportunity through the Everyday Counts program to subscribe to the Crowdsourcing e-news, and we have a fairly regular posting of information, tidbits of information that's happening around the country on what folks are doing in the crowdsourcing area, and it's usually a good source to keep it up to date with the latest happenings. So the next thing that we'd like to do is move to some poll questions, and with these poll questions, I'll go to Vishali to take over here.
Thank you. I noticed that there was one question that was asked that we didn't quite cover, and I don't know if we have a minute or 2 to answer that. And that is, are there any policy or process issues with regard to the use of image information that Nexar and the RTC used for work zones? I'm wondering if you guys could spend a minute or 2 on that. And then in the meantime, please feel free to answer for all of the 4 questions here.
You want to take that, Brandon?
Yeah, absolutely. So I can't really speak on the on policy, but I can tell you that from a data privacy standpoint, we do take data privacy very, very seriously at Nexar. So before any of our data is made public, there are a few things that we do. We completely strip it of all personally identifiable information. We run it through a detection that removes all license plate frames, so blurs out all license plate, I'm sorry, not frames, blurs out all license plates, blurs out all faces, crops all images in the event that we're able to see, say, a dashboard or something that's on a dashboard that's going to end up being able to track a user. All of that is automatically cropped out before it's placed onto the platform. And we only supply our driver analytics data in aggregate, so it's not able to be tracked back to an individual user. We are fully CCPA and GDPR compliant, and we take several steps to make sure that not only are we compliant, but we end up expanding on those models and making sure that that privacy is never a concern.
And I could add to that, as far as the RTC is concerned, our lawyers were very adamant that the contract needed to specify that Nexar owned the images. So if there's some sort of suit, somebody subpoenas us for an image, then Nexar will handle that for us until we download it and put it on one of our put it on our network or something like that, and then of course we've touched it and it is ours. So that information is discoverable, but Nexar owns it, and it's exactly the same model that we use for the videos that are on our buses and stuff. So just a little different application, but the same concept. Hopefully that helps.
Thank you, John. So now one other thing we wanted to point out is if you do go to the FHWA Everyday Counts Round 6 crowdsourcing page, we have 5 new case studies. They're each 2 pages, and they sort of highlight the journeys 5 different agencies took in the use of crowdsourced data. So you can definitely go to the site to access that. And then just before we close, we kindly request that you complete the 4 polling questions you see here. The first one on the upper right is, what topics would you like to see in upcoming webinars? And so far we have a couple of answers talking about road safety, any kind of near-miss identifying type capability, or if an agency has a platform in which audiences can follow along and navigate the platform. So we will look into those. And then the other questions down below are questions 2, 3, and 4. If your organization wishes to share a use case for crowdsourced data, please let us know. And then we do strive to make these webinars useful from a perspective of a practitioner. So we'd love your feedback on whether you would recommend the webinar series to a colleague, and how informative and useful was this specific webinar today. So thank you for all of those that have already responded, and if you haven't, please do complete those polling questions. And I think with that, we will conclude the webinar in about a minute. And thank you very much for attending today. Over to you, Kevin. I don't know if you have any closing comments. All right, then.
Thank you. And sorry. I was just muted. I had to take a second. Thank you, Vaishali, and thank you to our our presenters, to our moderator. Thank you for attending. Like I mentioned, or like it was mentioned previously by Greg, a recorded version of this webinar along with the presentation slides will be available on the NOCO website. On behalf of the National Operations Center of Excellence and our presenters, thank you for joining us today, and have a great rest of your day.
Thanks, everyone.